And we are live.
Hi everyone, welcome back. So our next speaker is Rohit Sanjay, and he's going to be talking about unit testing Jupyter notebooks with a project called Testbook. Over to you, Rohit.
Yeah, thank you, sir. So my talk is titled Unit Testing Jupyter Notebooks, and we have built a library called testbook, which helps you do just that. My name is Rohit Sanjay, and so this project was built as part of the Google Summer of Code program, which happened earlier this year. And it was built and it was done under the project under the organization called Interact, which is again under the larger organization called NumFocus, which sponsors events like SciPy and other scientific toolings in Python. So about us, that's me on the left. You can find me on Twitter at I'm Rohit Sanj, and you can find me on GitHub at Rohit Sanj. And it was my mentor during the program was Matthew Seal. He's the CTO at Notable Inc., and you can find him these links. So at a scientific conference, I think it's necessary to give a brief on unit testing. Whereas Jupyter notebooks, I'm sure most of you would be acquainted with. So unit testing in literally one line is it's just when a single unit of source code is tested individually. So if you have let's say a component which interacts with multiple other components, but you only want to test the functionality of that one component, that's when you write a unit test for it, and you would mock its interactions with other components, because you don't want that component to have any dependencies. So that's a little bit about unit testing. So now I'm going to talk about the context behind why we created testbook. First of all, Jupyter notebooks can get very messy. If any of you have worked with Jupyter notebooks, you know that the code is just sprung about and there's a lot of print statements everywhere. So code written to conduct data science experiments can get messy. So you need to enforce certain good coding habits to have it become maintainable and easily refactorable. And some of these good habits could be you can use functions to abstract away the complexity. So rather than just putting the code in the cells, you can put them in functions instead. You can bring code out of the notebooks and put them into Python modules, and then import them into the notebook. So then you can test those Python modules independently. You can apply test-driven development, and you can make small and frequent commits. So I've bolded apply test-driven development because that's where testbook sort of steps in to help you test your Jupyter notebooks. And we'll talk more about that in the coming slides. So test-driven development for Jupyter notebooks. There are a few approaches that have been tried and tested up until the creation of testbook, which is, first of all, you could write integration tests, which just runs the whole notebook as one unit. And there have been tooling developed by the folks at Netflix called Papermill, which is again another library under the Interact organization. So Papermill lets you parameterize and execute entire notebooks, and in some cases it can be used as integration tests for integration tests. But it doesn't really test the complex logic. Like it just runs the entire notebook and reports any errors. So it doesn't really test the logic in the notebook. Otherwise, you can write the tests in the notebook itself, but then it gets messy. I mean, you wouldn't want your source code to live right next to your tests, because as it says, it adds a lot of noise to the document. Because when you look at and also when you run the notebook, you're running the tests as well. So let's assume that some arbitrary test takes a long time to complete. You wouldn't want that to be paired with the source code. And also another way, which is what has been adopted so far, is you can refactor the code out of the notebook and write them in separate Python modules, which can be then independently unit tested. And this is what I had said earlier as well, and which is basically how all Python modules are tested. So why do we want to test in general and also for notebooks? First of all, you would want the notebook to be reliable in the future. Like there are multiple instances where a notebook written on day 0 wouldn't run on day like X. So because of multiple library version changes and multiple other versions of probably the environments. So to make it reliable, to make the code easily reproducible, you should just simplify the code wherever possible, and you should define clear method or API boundaries, like basically define exactly what the method is doing or the function is doing, and then again test those methods, and also repeat the same process whenever the inputs or anything, whenever the source code changes. And in professional settings, this is referred to as productionizing your code. And before testbook, this could be difficult for Jupyter notebooks. So this is where testbook comes in, where it helps you to unit test Jupyter notebooks. So testbook is a unit testing framework for testing code in notebooks. With testbook, you can now write like PyTest style unit tests for notebooks in separate Python files. So you'll have a notebook as one component, and you can have separate Python files that test these notebooks. And since you're unit testing, you can now write maintainable and reliable Jupyter notebooks. So this is a simple unit test using testbook. So if you have a function here in a notebook, which just adds two inputs, you would write a unit test like this in a separate Python file. So don't think that this is in the notebook itself. So you assume that this is in the notebook, this is in a Python module, and you just import testbook. And basically, I would just urge you to focus on this. So it looks like a normal unit test, except it's in a Python module, and it's completely separate from the notebook. And I'll talk a little bit more about how it works, because it gets a reference to this function. So we'll see that. So another example would be if you want to test a class, maybe, which has an init and a say hello method. So first of all, you would get a reference to this foo class. You create an instance of that class, call it bar, and you call a method, and then you assert. So this is like exactly how from this line onwards, it's exactly how you would test that function if it was probably in the same Python module. So that's the power of testbook, where you write your conventional unit tests, except you write it, I think I've said this multiple times by now, but you write it separate from the notebook. So how testbook works? So testbook works by creating reference objects, as you saw that .ref method, and these reference objects hold a reference to an actual object in the notebook. And all attribute accesses and assertions performed on these reference objects are internally pushed down or injected into the kernel. So if you do like bar.sayHello, it will be converted into a code. I mean, there's not too much complicated logic behind that. It's just the attribute is parsed, and then it's injected as text into the kernel, and then it's run, and the output is fed back into the testing process, which is separate from the Jupyter kernel. So now I'll quickly brief over the features of testbook. And actually, I think I've covered most of it, but just to give it in a concrete sense. As I said multiple times, you can write conventional unit tests for Jupyter notebooks now. So you don't have to learn a new type of testing to use testbook. And this is actually a like referencing some other unit testing, or let's say testing frameworks that have come up for Jupyter notebooks so far, where you have to where they've developed their own style of API, where they have developed their own API for testing notebooks. So I mean, that causes a learning curve, and you wouldn't really want that for normal testing scenarios. So we have designed the API in such a way that it's intuitive and it fits well into the general notion of unit testing, like I showed you earlier, the two lines which are conventional. So yeah, you would write tests for notebooks just like how you write tests for normal Python modules. So the second feature is you can execute all or some specific cells during a unit test. There's another cell called cell 2. So you can choose to execute only these 3 cells, or you can choose to execute all cells by passing execute equal to true. You can also pass a range of cells and so forth, so on and so forth. You can also share kernel context across multiple tests. So assume that a notebook takes really long to run, but you want to run multiple tests on it. So you wouldn't want to run that notebook every time you run a new test. So you can create a fixture using PyTest, and you can run multiple tests using that same context. You can perform patching of objects in the notebook. So you would want to patch maybe network requests or file IO, because you wouldn't want those files to actually appear or that network request to actually go out. You may end up bombarding your production API. So you would want to patch out those network requests, and you can do that using using testbook. So you can patch those objects in the notebook to make sure. So here we are assuming that there's a method called bar, and we are getting a reference to bar, and we are calling it, and we assert that it was called. So this is a very straightforward test. Nobody will write a test like this, but this is just for demo purpose. You can also inject code into Jupyter notebooks, which is actually the secret sauce of how testbook works. I mean, every sort of the ref API, all the patch API, everything works by injecting code into notebooks during runtime. And as I said, all assertions are also injected into the notebook. So if you need to perform any assertions, you can instead write that assertion code and inject that itself into the notebook and get the results of that. So if you see here, I've injected data equal to 1, 2, 3 into the notebook, and then it's run automatically. And I can create a reference object, and then I can write the test, which is assert data is 1, 2, 3. Also, it works with any unit testing library available. So because testbook only allows you to do the assertion part of the equation, and the part where you check if it's true or false, that you can do using PyTest, you can do using unit test, you can do it using Nose, or you can do it using your own in-house testing framework. And this was an intentional design choice. So because it's we wanted testbook to be pluggable into any unit testing library. So who is testbook for? So if you want to know if you should use testbook or not, we've added a bunch of questions that you should ask yourself. So basically, if you want your code to be working a few months later, then the code that resides in a Jupyter notebook, if you want that to be maintainable and reusable, you should consider using testbook. So if you're sharing this notebook with someone else who's going to run it, if the inputs for the notebook are going to change, if you need the notebook to run in the future, are you going to automate notebook execution on a schedule, which is like a cron job kind of thing? So if you're going to do that, then you want to make sure that your notebook runs as expected, and hence you can use testbook. So if yes, then testbook is a good tool. So coming to this is the end of my talk, where so testbook is it's a very nascent library. It was just we built it. We did its first release only around 5-6 months ago. So it's really nice to see that library. Actually, one library is using it as of now, which is called Arc Analysis. So I just wanted to show that testbook has been adopted, and it's being considered as well. So Arc Analysis is currently using testbook in production, and just linked a few PRs if you want to check it out. So and we learned a lot from how they use testbook. So we are trying to modify our APIs to sort of suit their their usage of our library. And another one, NB Cell Tests, which is a library built by JP Morgan Chase. I mean, the team at JP Morgan Chase. They have also considered deferring some responsibilities of unit testing to our testbook library. And the roadmap of testbook. So what's coming up is the support for code coverage across notebook files. So if you've heard about code coverage, it just tells you what percentage of lines of code have been hit by your tests. So then you know that all branches or all parts of the code have been covered. And also we want better support for non-Python notebooks. As you know, Jupyter supports all sorts of kernels like C, C++, Java, and so on. So we want to sort of make testbook a library that can support non-Python notebooks as well. And we're also happy if you'd like to contribute, even docs changes, any sort of contributions are welcome. And that was my talk. You can find testbook at github.com/interact/testbook and just drop a star. And you can install testbook by doing pip install testbook. And that's pretty much it. Thank you.
Thank you so much. That was a really nice talk. Our first kind of developer-friendly talk today. So there are a few questions at this point. I'll ask them. It's really nice to see this, by the way. The testing for notebooks has been one of the big pain points. Right. So the first, we have quite a bit of time for questions. So first question is, Manikant Roy is asking, what I get is IPyNB is being passed to Python script for testing, but where are you integrating both? And I gave an interim answer saying that it's through the kernel and that the TB object passes it back and forth. But can you please elaborate or correct me if I was wrong?
Sure. So that's absolutely correct. The IPyNB is being passed into the script for testing. We use an underlying library called NB Client, which is again developed by Matthew and his team. So what NB Client does is it uses it spawns a Jupyter kernel, which is basically what runs in Jupyter Notebook when you spawn a Jupyter server as well. So, but it just spawns like a headless Jupyter Notebook you can think of, and we can then interact with that using the NB Client library. So I guess the question is, where are you integrating the two?
Both. Yeah, integrating both. So yeah.
Okay.
So I would think that your TB object is your integration point, right?
Yes, the TB. Yes, exactly. The TB is a wrapper on the NB client. Right. The TB is called testbook client. So testbook, the TB is what makes the magic happen. Yes.
Okay. So since there are no more questions, I have a bunch of questions.
Okay. Sure.
One of which is, so if you are essentially handing it off to another client, so essentially your kernel is running on a separate process. Is that correct?
Yes, absolutely.
Okay, so which means your notebook is isolated from your test script. Essentially, your test script is just talking to a separate client that's running on the.
Exactly. That's one of the reasons why the variables in the notebook are not readily available with the testing process. Yeah. So that's why I need to create those reference objects to sort of interact with the.
Right. Okay, so one more question's popped up. Shashidhar is asking if most of the times Jupyter notebooks have good amount of data to work with. How does it scale or work with such scenarios?
Yeah, so the thing with unit testing is you wouldn't test your sort of complex. You wouldn't test a particular logic with production data. You would test it with a smaller sample of that data. So the answer to that question would be it doesn't need to scale because it's not meant to scale. You would only test using small set of data, which would again be available in probably a tests folder or something like that.
I guess within that same question is the question that, so let's say usually if I'm using a data analysis notebook and I want to write tests for it,
yeah,
if you say execute is true, I understand that it's going to execute all of the cells. Is that correct?
Exactly.
And you
Yes.
get the whole namespace is available.
Yes.
So the problem with that is, so if I have this massive 10 GB file that I'm loading in that notebook,
Got it. Yeah.
your only option is to basically say explicitly request certain cells to be tested. Is
Exactly. Yes. Yes.
okay.
So yeah. Sorry. Go
Are you
ahead.
thinking of things like, annotating some of the cells, saying, "Hey, this is testworthy. This is not testworthy." Is that something that you're thinking about as a roadmap?
Exactly. So you can tag these cells, as you said, annotate, and you can choose to execute only those cells. So, for example, as I said, you would obviously want to execute an import cell because you want those namespaces to be available, and you would want to only execute that cell which contains the logic you want to test. So, and you would skip the cell which contains the data loading or whatever. And if you want that data variable to be available, you can actually inject the cell just before the cell that contains the logic to have some dummy data like tb.inject and then data equal to some list. So,
Right.
so yeah.
Right, but I was asking in terms of actually having easy textual annotations. See, otherwise, if you have to edit metadata, are you editing metadata on the notebooks, or is it?
Yes, I mean technically yes, because you would have to go to the Jupyter Notebook UI and click view tags.
Which is a bit annoying. So maybe.
Okay, so you meant like having like a comment or something in the cell.
Right, like for example, I find the use of comments in the, if you see Visual Studio Code, you can just like put a percentage or something and makes it. If you can think of something like that, that may make it
Sure.
Perhaps a bit easier. Maybe some just ideas. I don't know.
Sure. So there is another library called nbval, which does exactly what you are talking about. But that cell is marked as a test, so that's what they do. But I understand what you're saying, and I actually discussed this with Matthew, my mentor, and he sort of dismissed the idea because he said the parsing of Jupyter Notebook cells is not too fancy, not too great. So we sort of dropped the idea. But sure, we'll consider it.
Yeah. Okay. Yeah. Sure. Or if there's an easier way to just quickly annotate a cell, like just click a button, and plug in that you can say, hey, this cell is a test, and it sort of internally annotates, or maybe have a decorator that you supply saying, if I want to mark a function that I want to be tested, that you can.
Yeah.
Okay. One more question is from Shashidhar: does it work with virtual env?
Yes, testbook is just a Python library. You can install it anywhere you want. You can install it on a Python virtual environment or on any Conda environment. So yes.
Okay. So my final question is: so your testbook paths, do they have to be absolute, or can they be relative?
They can be relative.
They can be relative. Yeah. Okay. Sounds great. Okay. So thank you once again. That was a really nice talk. And we actually break for lunch now. And we will reconvene at around 1:30. 1:35 we will start, but we may have a few announcements at 1:30. So see you all. I hope to see you around on the chats and attending the other talks and on chat.sci-fi as well. Okay, thanks Rohit. Thank you everyone.